Let's look at something here. So let's go x squared minus 2x minus 3 equals 0.
Okay.
Okay. So to solve by completing the square, you move the number to the other side of the equation. Like that. If it's already on the other side of the equation, then you don't have to move it.
And then do you take 2?
-2.
-2, sorry. And then you usually like what, chop that in half and have a
Exactly.
-1.
Very good. And then so you divide by 2.
Yeah. Which
And then
is
what
1.
number goes there? Yep.
1.
+1 on both sides.
Yeah.
Okay. Now the right hand side becomes 4.
4. Yeah.
Okay. Now
Then you
that's done.
square it.
You're done completing the square. Now you're going to square root both sides.
Yes.
When you square root, how many solutions are there? What happens to this thing on the right here? What do I have to put in front
2
of it?
solutions. It becomes
Yes,
plus or minus.
exactly. Good. So you write x minus 1 equals ±2, and you're almost there. You have to add 1 to both sides. So x equals 1 ± 2. You can't combine the 1 with the 2 yet. You got to separate it out here. 1 + 2, 1 - 2.
Yeah. So 1 is 3 and 1 is -1.
Good. Okay, let me give you one to try.
Okay.
So this is the type of problem where they already moved the number to the other side, but the way it will appear is it'll be smushed together like this, and you have to know to move it left and leave a space there. Is that clear?
Yeah.
Okay. This one also has nice solutions, so go ahead and give this a try, please.
You would chop 6 in half, right? And then
That's
make
right.
it x plus 3x squared.
Just the 3 without the x.
Yeah. Yeah, no, sorry. And then you would put 9 in each one of those boxes.
Yes. You're almost there. Keep going.
And then that would x plus 3 squared equals 4.
Okay, keep going.
And then you square it, plus or minus x plus 3 equals 4, x minus 3 equals 4. Subtract 3, x equals 1, x equals 7.
Okay, good. Any questions on that?
No.
I'm sorry. I might have heard the wrong answers. I heard a 7 in there. So did you take the square root of both sides?
Yeah.
So that becomes ±2.
Oh, I didn't do that. Yeah, I didn't take the square root of 4. I kept it as 4.
So, hey, that's important. I'm not sure what to tell you to remember to do that. Somehow you
Yeah,
got to
I
remember
just
to,
forgot to
to,
do
yeah. I mean, there's a lot of steps here, but it is doable.
that. Yeah. We could
So it
try one
becomes
more
x.
then, I guess, after.
Yeah, I want to show you the other type that you might see on there, which is if it doesn't work out nicely, meaning the root isn't nice, let's go x squared minus 8x equals -10. Okay. All right, so again, you have to rewrite this such that there's a space. All right, now what happens? What goes in parentheses here?
16.
Say that again.
6.
16.
Yeah.
You're cutting it in half. Are you talking about the red
Oh, in the
space?
box, I thought you were saying. Oh,
Yeah,
no,
the red
4.
space is 16.
Yeah, 4 is in the parentheses.
Anything else besides that?
Or x minus 4
Good.
squared
Plus 16 plus 16.
equals
Now,
6.
what is the next step? This is
And
so important to do here.
you square it both and make it plus or minus, and be x minus 4 squared equals 3. Plus or
Square root
minus.
of 6. Square root of 6 is unknown. There's no way to reduce that.
Oh. Okay.
Right. So some square roots that square root of 1, square root of 4,
Oh
square root of
yeah,
9.
I forgot.
Most of them you don't know. And if you don't know it, that's fine. You just leave it as x minus 4 equals plus or minus the square root of 6.
Okay.
Now what?
And then it would be x equals 10 for one of them.
When you add the number, it can't combine with the root. So if this were reducible, then you could combine it. It's just 4 plus or minus the square root of 6.
Oh, okay. I don't really remember doing this.
Well, I guess what I don't know, and that's why I wanted to give you this last example. Sometimes the square root works out. Like the other ones we did, square root of 4 worked out. Square root of 4 worked out, but it may not. So if it doesn't work out, you still write it. You just put the number in front.
Okay. All right, I got it.
Okay, so based on your list here, we should move on to absolute value, graphing absolute values. Does that sound good?
That's good. That's good.
Okay, so let's just start with the parent function, the absolute value of x. Do you remember what goes in the table? What 3 values are necessary?
1, 2, and 3.
So you need 1
Zero,
negative, 1
1.
positive, and 0.
Okay.
All right, can you give me the values on the right, the absolute value of each of these numbers?
Positive 1.
Okay,
0, and negative 1.
the absolute value always returns positive.
Oh, sorry. Then positive 1.
Yes. So the graph of this, very important to have a visual. It's a V.
Okay.
Is that okay?
Yeah.
All right. Let's look at a new one. Let's say it's y equals absolute value x minus 2 minus 4. There's 2 transformations here. Do you remember either of them? There's one in here that's left or right. There's one out here that's up or down.
Down 4.
Okay,
And
down 4.
would it be right 2?
Yes,
Okay. I was wondering because I know some of them it's like the opposite.
it is. And this is one of those. This is one of
Yeah,
those opposite.
that's what
So
I thought.
here's why you have to know your parent function, because you're going to use those points and you're going to move them right 2, which affects the x, and down 4, which affects the y. So right 2 means, what are you going to do with this x value? How do you move it to the right? And if you need to, you can think, okay, here's -1, and I want to go right 2. Now it's at positive 1.
Yeah.
How does that happen? What's the math operation to do that?
Like adding 2 or something.
Yes. Yes. So right 2 means adding 2. You're going to add 2 to each of these x values. What's the new x values?
Uh, positive 1.
Okay.
and 1 on the y, or
We'll get
1,
to that. Don't
2,
worry about the y, just the x, just yeah,
2,
2, and then,
and 3.
okay, great. Now, down 4 affects the y. You know, you were here, now you're going 1, 2, 3, 4 down.
Yeah.
What's the math operation to do that?
Subtraction.
So you're going to subtract each of these y values by 4.
4.
Okay, so give me those values. 1 minus 4, 0 minus 4, 1 minus 4.
It would be 3,
Try again.
-3,
-3.
4,
Try
-4,
again.
-4,
Yeah,
sorry, and -3.
good. So the graph of
Let
this,
me get this down really quick too.
oh, sure. Yep.
I just want to like take little notes also, like on the side.
Sounds good. If you need me to pause like you did, just say so, and I'll.
All right, we're good.
Okay. Right. So let's have you try one here. Let's say that y equals absolute value x plus 1 minus 2. Give me the 2 transformations first, and then have you make the table.
Okay, down 2
Okay, down 2, and that affects the y.
and left 1.
Left 1. Okay. So I hope you wrote down your parent function. Did you? If you didn't,
Yeah.
you'll need it. Okay. So I want you to use that parent function and give me the new table, the new x and y for this.
Okay. All right. And the parent table is just -1, 0, 1 for the x.
Yes. And then
Yeah.
1, 0, 1 for the y. Yes.
Okay. Subtract 2. So the new table would be on the x would be 0, 1, and 2, and the
Okay.
y would be 1, -2, and 1.
When you go left 1, you're
-1,
subtracting.
-1, I
You're
mean.
you're subtracting 1 though. So the original was -1, 0, and 1. You're subtracting 1 from each of these. That's what left means. You're not adding 1 like it shows in here. So try that one more
Oh,
time.
yeah. Okay. So then it would be -2, -1, and 0.
Okay.
And then the y would be 1, -2, and -1.
These two are okay. I heard 1 for the first value here.
Yeah. Is it?
You're subtracting 2. 1 minus 2, same as down here, 1 minus 2.
Yeah, 1, right?
Is that what you mean?
Yeah.
Okay. How did you get -1 down here from the 1? The 1 on the
Oh,
left became a
no,
-1.
it was just 1.
Right, so it's -1. 1 minus 2 is -1.
Yeah.
Right, okay.
Sorry, yeah, okay.
Okay. I mean, it makes a difference because your graph will look really wrong, and wrong to the point the teacher can't really help you with points. So this thing always needs to have a V shape when you graph it. So if
Yeah.
it doesn't have a V shape, or if it doesn't have a V shape, make it have a V shape so that it looks the way it's supposed to, so that it doesn't, you get some points there. Okay, let's do a couple more examples. This is related to one of the other things you're asking about, so I'm gonna throw that in there. Okay, this one has two transformations. Right 4. Okay, you remember what this negative does on the outside?
Yeah, do you put a 1 in front of it?
You can. Yep, that's good.
Okay.
But what is the transformation? If you remember, if you don't,
Right,
that's okay.
right, or
We already dealt with that. The -4 is right for this -1 here. Do you remember what it does?
vertical stretch or reflection?
Reflection over the x-axis.
And it was one of those, yeah.
So it affects the y value. So the right 4 affects the x. So we start with our original table, -1, 0, and 1, 1, 0, and 1. Now right 4, what are we going to do to each of these x values when you go right 4?
Add 4.
Right 4. So give me the new x.
Okay. +3,
Okay.
4, and 5.
Now the y, the reflection over the x-axis, you negate the y. And it's important that you write negate, because if
What
it's
does that
positive,
mean?
it's negative. Well, positive goes to negative and negative goes to positive. So like 1 goes to -1.
Okay.
0 goes to 0. 1 goes to -1.
Okay.
Any questions on this? I'm going to give you one like it.
No. So if you just don't have a y or a number for y, you just negate it.
Yes.
Okay. Yeah, I got it.
Okay, let's try another one here. Y equals negative absolute value x plus 2. Two transformations.
Okay. One of the transformations is left 2,
Okay.
and the other transformation is a vertical stretch by -1.
It's a reflection, not a vertical stretch. A
Reflection,
vertical.
reflection by -1.
Okay. And then this affects the y value. So give me the new table after you've done the transformations.
Okay. For the x value.
Oh, x and y, whenever you've got them.
Okay. X would be 2, or not 2, sorry. 1, +1.
Are you giving me
Uh,
the after the transformation or the pre-transformation?
what do you mean? Yeah,
I
like,
already so I already know these. Like I don't want these because these we've talked about over and over again. I want the new ones. Like the whole point of this is, can you get from
yeah,
the this
yeah,
one to the one on the right? I just want these values. However you want to get them.
yeah. The first one would be 1, right? Because oh no, no, no,
Going
no, no, that's going
left
left.
to.
So it would be -3,
Good.
uh, -2, and -1.
Okay.
And then the y value would be -1, 0, -1.
Okay, so a couple more things, and this all applies to the quadratics. So we're making good gains here by doing this. Let's say it's 2 absolute value of x minus 5. Okay, this has 2 transformations. The down 5 is the second one.
Okay.
The first one is a vertical stretch by 2.
Okay. Yeah.
Okay, vertical stretches affect the y value. Down 5 affects the
How
y
do I know
value.
if it's a vertical stretch or a reflection?
The negative is what makes it a reflection.
Okay, let me get that down.
The negative is what makes it a reflection.
And if it's positive, it's a stretch.
Or negative. We could see like a negative. Well, and if another problem, we'll see like a -3. That's it's still a stretch. If the number in front is a number, it's a stretch.
Okay.
Okay, so let's make the table here. -1, 0, and 1, 1, 0, and 1. Both of these transformations affect the y value. Vertical stretch by 2 is a y, and then down 5 is the y. Now the order matters. You have to first do the vertical stretch, then do the down 5. Okay. So you can either do it all in one step, or you can do it in 2 steps. Do you think you would do it all together or in 2 steps?
2 steps.
Okay. So let's first do the vertical stretch by 2. You're taking every y value and multiplying it by 2.
Okay.
Can you give me those y values, please?
Yeah. You're multiplying it by 2.
Yes.
So it'd be 2, 0, and 2.
Okay. And then down 5. Down 5 affects the y value.
Would you be just subtracting it?
Yes.
Okay. Uh, -4.
Very good.
5, -5.
You're subtracting 2 by 5. You have $2. You owe someone $5. How much do you owe them?
Oh, you're okay. My bad. It would be -3,
Okay.
5, -5, and -3.
Okay. Let's try another one here.
Okay.
Y equals -3 absolute value of x. There are 2 transformations. There's the vertical stretch by 3, which affects the y. And then there's the reflection over the x-axis, which also affects the y.
And how can how can you tell if there's both of them?
The negative is the reflection always. If
Okay.
there's a number in front, it's a stretch.
Okay. Got it.
So what I'd like you to do, and I'll put 2 tables in if you want, is I want you to, and on your own paper here, give me the final table. You're welcome to make 2 tables.
Okay. Would you'd start out with multiplying or subtracting -3?
Yeah, we're stretching. What did we do in a previous stretch problem? What did we do when we stretched by 2?
Multiplied it.
Yes. So you should do the same thing here.
Would I multiply -3 or positive, just +3?
So if you want to do it all together, you can multiply by -3. If you want to do in steps, you multiply by 3 and then negate. They get you to the same place.
Okay. What do you usually think is like easier?
You said you wanted to do 2 tables, and that's fine.
Yeah.
I would do them one at a time.
Okay.
So multiply by
Um,
3.
then it would be 3, 0, and 3.
Okay, keep going. So you're
And
going to negate them.
and then it would be -3, 0, and -3.
Good. Okay, now is one of these like putting it all together problems, okay, where we do all the transformations that you might see. So let's go -2 absolute value x plus 1 plus 4. This one has 1, 2, 3, 4 transformations. I'll take any of them that you can see.
Okay. Up 4. Left 1. Vertical stretch by 2. And a reflection by 2.
Reflection over the x-axis. So
Reflection over the
just that. Okay, so we're gonna go through these one by one. Does left 1 affect the x or the y value?
The y value.
It's been a while, but when we go left 2, it affects the x. Left and right affect the x.
Okay. Okay. So yeah, x.
Everything else seems to affect the y in these problems.
Okay.
So this affects the x. Now, what are you doing to the x? Are you adding 1 or subtracting 1 when you go left?
You're subtracting 1.
Subtracting 1. So you might indicate that. I'm not sure. That's up to you. Stretch by 2, does that affect the x or the y?
I think it's the x. Or is it the y?
Vertical stretch by 3 is the y.
Y. Okay.
The key to doing well in this is to remember these, which one it affects, because when you start multiplying the wrong one, there's no partial credit. It's just all wrong.
Got it.
Stretch is like multiplication. So you're going to multiply by 2. Does reflecting
Stretch
over the
is
x?
the y,
Yes.
and reflection is x.
Reflection is y.
Reflection is y.
We just did that. It affects the y value. The y values were negated. They were positive, and then they were negated.
Yeah.
Okay, how about up 4? Does that affect the x or the y?
That affects the y.
Yes. And you're going to add 4 to each of the y values. Okay. So the order matters. I don't know what to tell you about that. We haven't really addressed it, but the order matters. It's always left and right, then the stretch and the reflection, then the up.
Yeah.
Okay. You want to do 4 tables, or you want to try and do it in one table?
Um, we could try to do it in one, I guess.
Okay. So let's do the x values first. Left 1 affects the x, subtract 1. Tell me what goes in this new position.
-2.
Okay.
-1 and 0.
Great. So you're done with that. The order matters. Okay. So first thing to do with the y's is multiply it by 2. So you're going to take this number right here, 1, and multiply it by 2.
So 2.
Then you negate it. So it becomes -2.
Okay.
And then you add 4.
Okay. 10. So it'd still end
Okay.
up being 2. Uh,
Okay.
0.
So do the same thing for the next one there. Multiply
For
it
the
by
y
2,
value.
negate it, and then add 4.
Okay. It would still end up being 2, 0, and 2.
It is not. I don't think you're following the steps here. Multiplying 0 by 2.
0.
Okay, then negate it. That doesn't do anything. Plus 4.
Oh, 2, 4, 2. Sorry, I'm not thinking. And then it would be 4 also.
Try again. Multiplying by 2, negating it, and then adding 4.
2. Right. It would
Very
end
good.
up being 2.
Yep.
Yeah.
Yes, very good. Okay. Now, the good news is everything we just did applies to a quadratic, okay? So we're gonna transition to factoring, but everything we just did applies to quadratic. So if this were a quadratic where it was minus 2 x plus 1 squared plus 4, same transformations, exact same transformations. Left 2, vertical stretch, I'm sorry, left 1, vertical stretch of 2, reflection over the x-axis, up 4.
Yeah.
I feel I want to make sure like it's the same rules. And the parent function that you start with, just to keep it super simple, is exactly the same.
Okay. All right, got it.
The major difference is that while this one's a V, this one has a U. It's got to have a little more curvature to it.
Yeah, okay.
You sure you got it?
um yeah.
Okay. All right. So let's transition to factoring. The first type of factor we're going to cover is GCF. 4x squared minus 8x. What is the GCF between these? What goes into both 4 and 8?
2.
Bigger than 2?
4.
4. And then what about x squared next to the first? What's the common one between them?
Wait, what?
The between x squared and x to the first, what is common between them?
They both are x's.
They both have an x, yes. So your greatest common factor is 4x. And what you write in parentheses is based on dividing each of these by 4x.
Yeah. So would it be 1x and 2x?
Yep. Minus, nope, the x's cancel.
So it'd be x minus 1.
8 divided by 4 is 2.
Well, yeah, but 4 divided by 4 is 1. So do
Okay,
those just cancel out?
let me write it off to the side here so you can see. Yes, the x's cancel, and yes, they make 1 and 1, that's fine. It's still 8 divided by 4, which is 2.
Okay.
Now the other one, 4x squared, is really 4 times x over 4 times x. 4's cancel and the x's cancel. What's left over?
Dx.
Just the x. Okay, now not to overwhelm you, but let's just say we were solving now. What do we do next with these?
Would we add 2?
You set them each equal to 0 first.
Okay. So I don't really know what to do from there.
What is the 4? What's the math operation between the 4 and the x?
Well, multiplication.
So you undo it with division.
Yeah.
What is 0 divided by 4?
X equals 4.
Nope. Try again. 0 divided by 4. You have nothing to
Oh,
share.
0, 0, 0, 0, sorry.
Yeah. How about the one on the right? How do you undo this?
Addition.
Okay.
X equals 2.
Try another one. Go 9x squared plus 18x. So it's another GCF factoring.
Divide by 9.
Okay, 9 is part of the GCF. What else?
And 2.
Nope.
Or,
Look at the x's. X squared and x to the 1. It's just like the last one.
Just X then? Or,
Yeah. If there's an x in both, you can at least pull out an x.
yeah. You don't just normally just add the X, like,
No,
no.
no. Divide each of them by x.
Okay. And then it would be X minus, or X, it would be X plus or minus?
Well, look at the sign in between them. What is the operator in between?
Plus, or addition.
Okay, so that comes down to the x plus
2.
Here it is. Now, let's say we're solving. Set it equal to 0.
And then it would be, you would have to set them both to 0, right?
Okay, to do that.
And then it would be X equals 0 and X equals -2.
All right, so that's your GCF factoring. You want another one of those, or do you want to move on to the next type of factoring?
We should probably do one more. It's not
Okay.
like really-
Let's go 4x squared.
And isn't there another factoring that you do like X minus 2, X plus 2?
Yes, there's
Yeah.
5 different types of factoring, plus completing the square, plus quadratic formula. We can't cover them all, but you can
Yeah.
also look back at some previous lessons as well.
Yeah. Okay.
All right, so let's go, sorry, let me change this up here. Let's go 6x squared minus 12x.
You would get 6. You drop like the 6 down, or not drop it down, but
I want you to solve this one on your own. Just give me the final answers here. I'm happy to
okay.
scroll up if you need me to.
Hold on. Okay, yeah, you can scroll up now. My two final answers are X equals 0, X equals 2.
Okay, so let's move on to the next type of factoring.
Okay.
All right, so let's say it's x squared minus 36 equals 0. This is exactly what you were talking about. This becomes x minus 6, x plus 6 equals 0.
Yeah.
This is called difference of squares.
Okay.
Okay, now you have to set each of these equal to 0. So you still get 2 solutions like we've been talking about all night. You get 2 solutions with quadratics. What are the two solutions?
It would be X equals 6 and x equals -6.
Good. All right. Now, truthfully, you're not going to get a problem that's just difference of squares. It's going to look a little bit more sophisticated like this. So I'm going to throw this one at you. The first type of factoring you should always try is the GCF. Is there a
Okay.
number that goes in both 4 and 100?
Yeah,
What is
2.
bigger? Bigger
4.
number. 4. So you divide each of these by 4. Tell me what goes in parentheses.
X minus,
X squared.
x squared minus 25
Okay.
equals 0.
So now this x squared minus 25 is a difference of squares. What
Yeah.
does it become?
Then that becomes x plus 5, x minus 5.
Good. Now, in terms of solving, you only set the ones with x equal to 0. You set x plus 5 equal to 0, x minus 5 equal to 0. The 4 does not have an x, so you ignore it.
Okay. And then your final answers would be x equals -5 and x equals +5.
Okay. Let's have you try one here. Let me know when you're ready.
Okay. Yeah, you can go for it.
2x squared minus 32 equals 0. I just want the final answers.
Can you scroll up really quick, Matthew?
Sure. Sorry, my cursor, there it is. All right.
Thank you. My two final answers are x equals -4 and x equals 4.
Very good. Okay. The last type of factoring is that we're gonna have time for is something like this: x squared minus 8x, minus 20. Okay, so you're looking for two numbers that multiply to the last. Okay, so in this case, minus 20, but add to the middle, which is -8. So these are the most difficult ones to figure out. Two numbers that multiply to minus 20, but add to -8. So the answer here is -10 and +2. That's the challenge of these, is coming up with these numbers. I hope
Yeah,
you remember doing this. I mean, you're going to get
I
some.
do remember doing this. Yeah.
So it becomes x minus 10, x plus 2 equals 0. Okay. You still have to set each of these equal to 0.
Okay, and then from there you just do the same steps as we were doing in the previous
Yes.
problems.
Yes. So here's one for you to try. X squared minus 1x minus 12 equals 0. So you're looking for two numbers that multiply to minus 12, but add to -1.
Okay. Would it be +4 and -3?
Other way around, those add, you gotta be, very careful here. Those add to +1, you want a flip of those.
Oh, okay, -4 and +3.
And that does make
I
all,
thought that one was positive for a second. I didn't really see the negative. But yeah, I see now.
but you're not done. You gotta set them each equal to 0. What would the final answers to this be?
X equals 4 and x equals -3.
Very good. Okay. All right. Now, real quick, let's just say you got a solution like this: 2x minus 1 equals 0. How do you solve this?
Adding the 1.
Okay, add 1, and then you have 2x equals 1. What's
Yeah.
next?
Divide 2.
Divide by 2, so x equals 1/2. Good. Okay, we did get through everything in your list.
Yeah.
The transformations are probably the thing to look at